For our first tutorial, we will be creating a simple dashboard application in which users can post and edit and delete posts. There won't be any high-level security on the pages, but we will have a login for each user. So open up Visual Studio 2019 and go to Create New Project. Select from the next page, select ASP.NET Core Web Application. Click Next. In the Configure Your New Project page, select the project name text box and enter in a name of -app. Then click Create, and Visual Studios will take you to another page which says create a new ASP.NET Core web application. Make sure that .NET Core is selected as well as ASP.NET Core 3.1 at the top of the window. And make sure you have a web application MVC controller of type project selected. Go to Authentication and click Change. Rather than select No Authentication, select Individual User Accounts and then click OK. Then press Create, and Visual Studios will automatically set up the basic structure of your web application, as well as install a few libraries that will make your life a lot easier. Okay, so as you can see, we have 5 folders created by default: Area, Controllers, Data, Model Views, and the www root folder. The www root folder holds all display files, things that control the way your site presents itself. JavaScript files, which are used for client-side operations, as well as JavaScript libraries. So basically the www root folder holds files that will run on the client's computer rather than on the server that's hosting the website. Controllers are where all the magic happens on the server. This folder holds controller files which run business logic as well as interact with your database. Put simply. Next, we have the models folder, which basically holds classes that represent your underlying data storage structure. Don't worry if that doesn't make sense now, but it will later on as we delve into actually learning about things. So there will be a class for every table in a database in this folder. Then we have the views folder, which holds the HTML files, which are basically what is sent to the client, the browsing computer, and it holds the actual web page. If we look at an example, index.cshtml, we'll see this markup, and this is what is displayed to the actual client. At the top, what we see of this index.cshtml page is something called razor syntax, which allows for C# code to run on the page, on the server, in order to render more complex code-related operations for generating your HTML. So this is by default what Visual Studios creates for us when we select authenticated web app for individual accounts. So let's take a look at what has been created before going into the files below, the app.settings .json file, the program.cs file, and the startup.cs file, and the areas folder. So I press the play button at the top of the Visual Studio's Designer, and it opened up in our browser a page, which is the web application, the default web application that's running. So we have the following: a dashboard application. That's the name of our app, Dash App. It says, welcome, learn about building web apps with ASP.NET Core, just like it says here. So in HTML, we have these tags, which describe what each element is. So the a.href equals this is basically a link. And the end of the link is signified by the /a. And here we go. If we were to click on this, it would take us to the actual Microsoft page if I was connected to the internet, which I'm not. So next, on the very right, we have the register and login links, which is what was created by default when we added authentication to our app. This allows us to create accounts, and Microsoft Visual Studios automatically created the pages behind that. So we have a login, which allows us to log in, and we have to the actual application as well as a register, which will allow us to create a new account. So let's go ahead and create an account. So I'll call it nealin.@gmail.com, and then I will give myself a password of let's say password capital P 123 question mark 123 question mark, and register. But we run into an interesting problem here. Basically, the underlying storage application hasn't been created. So in order to create the tables in the underlying storage application, which is set up by default, we had to click Apply Migrations. So we click Apply Migrations, and it updates our database, which is basically where we'll store data that we want to save, so that it'll exist after we close our application. So now it says it's created it and says try refreshing the page. So now we should be able to create it without getting that issue. Okay, so to recap what we have just seen and learned, Visual Studios did the following by default when we created the application. It installed Entity Framework Core, which is basically code used for accessing our database, aka our underlying storage structure used to persist data in our web application. It also installed the Identity Framework Core, which is code used for giving us the ability to log in and register users. And it also created a sample template website for us. And this was all pre-configured by Visual Studios. Furthermore, it created the following folders: the area folder, the controller folder, the model folder, and the view folder, and the www root folder. The area folder is used to segment our website code as it gets more complicated into different areas, as it gets larger, for easier organization. Currently, some of the code for our login and registration, which was installed by Identity Framework Core, is stored here. So if we were to take a look, we'd see identity and we'd see some pages. Next, it created the controller folder, which contains the files that do operations and processing and business logic, and this code runs on our server. Business logic, is put simply, is basically a term for business-related manipulations of the data that we push to our server. So as we look in the controllers folder, we can see the home controller, which was created by default, and it has several methods which basically return information to our front-end web application and tell it which views to use. We have the www root folder. This folder has files that will run on the person viewing the website's computer. The CSS, the JS, and the lib folder, as well as any media that you might want to have on your associate with your web application, like movies or music. The app settings.json file, which is in the root of your project. This file contains configuration information that's not part of the code. So if we go and look at the app settings.json file, you can see here we have a connection string configuration, and within it says default connection, and it has our database connection string, as well as logging information and allowed hosts. So that's all done for us by default. Next, we have the program.cs file. This is the first file to run when our application starts and it fires off the web application. So if we go here and go to programs.cs, we'll see it automatically generated code for us. And the startup.cs file. This file contains our web application configuration information and middleware. Middleware is basically any segment of code that runs whenever a person accesses anything on your website. So basically when they go to a page, this segment of code will run automatically, and website configurations, like if you want to add logging or other such things. And that's what's created by default. So since we're making a dashboard application, the first thing we'd want to do is create a table that will hold our posts, because every user that logs into the application should be allowed to create a new post. Don't worry if you're not getting this now, because we're going to revisit these concepts in a more structured way later on. I just want to expose you to these things so you'll be thinking about it and you'll remember it later as we actually learn it. So we click add, and automatically this structure is created for us. The namespace, which is like a grouping of information in classes, a public class post, which is basically the table that we're creating. So go to the top and press stop, because we can't really commit or save any changes unless the application is not running. So we're going to create 3 fields. Type in prop, tab, and it'll generate a property for us, a getter/setter. And we'll call this ID, because each post we want to have a unique numerical value associated with it. The next property we'll create will be a string, and it'll be title, which will be the title of the post. The next one we will create will be called description. And finally, we will create a date time property and call it create date. And by default, we'll give it the value current time, which is, this is basically an acronym for the current time. So you say datetime.now, and that will automatically load the current time. So every time a post is created, it'll give that post the current time. Okay, so we wrote a little bit of code. This is the name of our table or data storage container. This is each of the actual attributes of that data, the ID, title, description, and create date. Now let's go to controller, right click on controller, and click add new controller. From this screen, we're going to add a new controller. We're creating a new controller. MVC controller with views using entity framework. So what this does, if we read on the very right, it says an MVC controller with actions and razor views to create, read, update, delete, and list entities from an entity framework data context. So basically what this will do is automatically create the pages that add, delete, and update. It'll automatically use a template. Okay, so the actual code for our post controller has been created. And let's see what happened. We see a post controller was created here. Now let's go to views, and we see 3 folders. So what are these 3 folders? We have a home folder, a post folder, a shared folder, a view imports.cs HTML, a view start.cs HTML. So what are they? Well, the home folder corresponds to the home controller. So each file, the index and privacy CSHTML has a corresponding index and privacy method in the home controller. It returns the view. So by default, this will map to these 2 files. But how? What is causing it to call or no look in this particular place for this file when we just specify in the post controller or in the home controller that when we go to the index URL that we want it to return the index file. Well, if we go to our startup.cs file and scroll to the very bottom of it, we will see this segment of code which says this is the pattern of our URL. So the controller will be home, which will be the first part of any URL, and then the second one will be the action or the method, which is index. And if there's a number after that, it'll be automatically passed in as the ID, as a variable ID. But these don't have numbers, so that's why it's calling it. So whenever you create a controller, by default it has the controller name, which is ignored in most cases with regards to the URL. So it'll only take the first part of the actual controller's name, which is home, and it will send you to this actual file. So if we look at this actual action, so if we look at the post controller, we see the same thing takes place. So we have a post controller, and we have the main page, which is index. We have the details page, which will tell us details about it. We have the create page. We have the edit page. And we have the delete page. The delete confirmed page. And so let's look. So we have a create, delete, details, edit, and index page, just like the actions we showed before. So okay, let's take a look and see what we just did. So click the play button. Okay, so our application has started up and it opened up in our browser. As you can see, we're still logged in. But where is our notes? The reason why the notes page isn't showing up is because we didn't modify the home website in order to point to it. So if you recall what I said previously, our post page. If you recall what I said previously about the actual URL, our posts controller will have the URL subfolder of posts, and then we'd refer to the index action, which is the main action. Click enter, and we get an interesting error here. A database operation failed while processing the request. What does this mean? Invalid object name posts. There are pending model changes for application DB context. In Visual Studio, use the Package Manager console to scaffold a new migration for these changes and apply them to the database. Add migration, migration name, update database. Okay. So basically what we forgot to do was add it to create this actual data structure in our database. So if we go to our application DB context, what we have to do here is confirm that the post model was added as a table. And because usually we would have to add this code ourselves, but since we created the controller through Visual Studios, it generated it for us. So now all we have to do is go to the Package Manager console, which is underneath in this tab, start it up, and run the commands that Visual Studio told us to run. So we first want to type in add migration, and we'll say posts table. And just like Visual Studio asked us to do, the next command we should run is to update database. And what this is doing is telling Entity Framework to create the post table for our database. It ran it, and it says build succeeded. So now let's retry running our application. We'll close that. Our application should run. So now let's go back to the post page, /index, enter. And this has all conveniently been created for us. A template, add, update, delete, and default page for our new posts. So let's create a new post to see what happens. Title, test, description, stinky, and let's select a date from the dropdown. Which is odd, right? We shouldn't have to do this because it should be created by default. So we'll modify that next. Click create, and we have to set the time as well. That's been set. Create. So even these input boxes have automatically check for us having entered in the proper details. So now if you see, our post has been created, and we have a test, stinky, and the create date all entered for us and easily available. If we were to click the details, we'd see it's shown, that row is shown in a nice convenient way. So let's go back to the list. If we click on edit, we have the ability to edit each of the fields and then save them. And then if we click on delete, it'll take us to a delete confirmation screen, and we could choose to really delete it or go back to the list. Let's not delete it yet. Okay, this is great and all, and this is what we were aiming for, but this isn't the end game. We still want to modify it to remove the create date. So let's go back to our application. Okay, so now we're going to be modifying our views as well as our controllers so that we don't see the create date. Because the create date will be set by default for us. So first go to your create controller, and we'll see this tag, div class equals form, and we see the create date tags here. Create date ASP4 create date, ASP4 create date, ASP validation for create date. We don't care about that. We don't want the create date in there. It's going to be set first by default in our model code right over here, right? So we took that out of the create. Let's go to the edit, and we will do the same. And we have removed it as an input from our form. And now let's go to our post controller and see if there's anywhere in this code that makes us need to actually send in the create date. So you see the bind for our edit, it's asking for the create date. So if we don't remove it here and we send a form post from our front end to our server code, it's going to complain and it won't let us. So we have to remove the create date here. And finally, we'll remove it from the create. So we removed it from the edit, we removed it from the create. And for the sake of things, let's just go back to our main model and go to the layout. And we'll do something interesting. What we're going to do is add a link to our notes page. So here we have the following options in our link. The ASP area, it's not a part of any area because it's not in the area folder. The ASP controller, which we will say is posts, not home, and the ASP action, which is index. And we'll call this view posts. We save it, and we'll go to our post controller, and we'll change the name of the view to posts. As well as here, we'll show posts. Press play. And it opens up in our browser. And boom, we're in our application. We can view our posts by clicking on the view posts at the top of our menu. Let's log out. Let's create a new user because we want all users to be able to create posts. Register that user. Confirm the account. Log in with that user. Okay, so stop your application from running and let's go to our post controller. Here we're going to use an interesting tag on this controller, and it's going to be followed by square brackets, and it will say authorize. That's it. Press Control period after typing that in and say Microsoft using Microsoft.asp netcore.authorization. Okay, so automatically the Microsoft.asp.netcore.authorization has been imported. So using is how we add libraries to a particular file using the using prefix and then the name of the library. Save the change and then press play. Once again, our application will start up. And if we go to view posts now and we're not logged in, it's going to ask us to log in. So we've automatically created a sort of restriction by using simply that tag. So let's type in our new user. I entered in the wrong password. Let's fix that. And now we're taken to the post controller like we wanted. And we can create a new post. Hello. Create it. And boom. Now we could all make posts on this dashboard. So for this exercise, that's the end of it. I'll show you how to do more complicated operations in future tutorials. Alright, congratulations on having completed your first web application. Till next time.